So we're asked to graph these piecewise defined functions. So we'll do this one up here first. Look, the first part is telling you how the function behaves. So this is like y equals 3 minus x. Look, x is to the first power. So that means this is going to make a straight line, okay? But the straight line only exists when x is less than or equal to 1. So here's a quick sketch of a graph. Here's where x equals 1. This first graph only exists on this side of the x and y grid. Okay, only exists over here. So we'll do that one in red when we do it. Okay, it's only on this side. So let's graph it. We'll do the next part. This is another part of the graph. We'll do that in just a second. So to graph this, again, like I said, you can take this and set it equal to y, because that's probably a more comfortable format. This is an equation of a straight line where the slope is -1, right? The slope is always the number attached to the x, and you got to take the sign with you, so that's a -1 for a slope. And the y-intercept is 3. So this graph starts at 3 on the y-axis, and then a slope of -1 means we go down 1 to the right 1 and put a dot. Down 1 to the right 1 and put a dot. But look, when I draw my line, I'm going to make an arrow in the top left corner, but I'm going to stop here, and I'm going to put a solid dot. Okay? And the reason for that is because this line only exists when x is less than or equal to 1. If it said just less than, then I put an open circle here. But that's why I stopped drawing that line there and I didn't connect it to this dot over here. And now we can graph this line over here. We have y equals 2x. So that's a straight line equation. That's y equals mx plus b, where m is 2 and b is 0, right? In other words, that means it has a y-intercept of 0. Starts down here. And the slope tells us to go up 2 and to the right 1 and put a dot. Up 2 and to the right 1 and put a dot. So there's our line, but this line only happens when 1 is less than x. In other words, look, you can flip that around, make the alligator's mouth still eat the same thing. This only happens when x is bigger than 1. So when x is bigger than 1, this is x equals 2, x equals 3, x equals 4, so this blue graph only happens on this side. So that means we need a straight line going up from here. And that's it. We've graphed this and this. We've graphed both pieces of the piecewise function. Okay, let's do this other one. This one has 3 pieces. Oh boy. 3 pieces for the price of 1. It's got 4 minus x squared when x is less than 1. So it looks like we're still using 1 as a turning point. But look, this is a different graph. This is quadratic, right? A quadratic usually looks like this. But if you multiply the outside by -1, then the quadratic flips its direction. Okay, so this is multiplied by -1. And then if it has 4 here, look, if you plug in x equals 0, so x equals 0 lands us somewhere on the y-axis. X equals 0 gives us y equals 4. So this quadratic is down 1, 2, 3, 4 units, and that's where it crosses the y-axis. But again, since x is less than 1, this graph only happens on this side. I'm going to stop my curve right here when I get to x equals 1. I'm going to put an open circle. Okay. So normally the parabola, if it didn't have this restriction, it would go all the way through, but since it stops at 1, that's where we stop our graph. And in this graph, look, x is to the first power. That means it's a straight line graph. It's got a slope of 3/2 and a y-intercept of 1/2. So halfway between 1 and 2 is our dot. And then we go up 3. So up 1, 2, 3, and to the right 2, sorry, because it's a 3/2 for a slope. So I've got my starting dot, my y-intercept of 3/2, and then I'm going to count out my slope. Up 3 units, to the right 2 units, put a dot. Up 3 units, just make a sketch, put a dot. But this graph only happens between 1 and 3 on the x-axis. So here's 3. When I draw this graph, I'm going to put an open circle where it's supposed to cross, like if we were to imagine these dots connecting. At x equals 1, it looks to be right here along that line. Oh, sorry, closed circle, closed circle. So closed circle here, and then it only continues its pattern until we hit x equals 3, and then it's another closed circle. So all these other dots need to be erased because they're not part of the function, right? Because this only happens, this straight line we just drew only happens between 1 and 3 on the x-axis. And then x plus 3, that's another straight line, slope of 1, y-intercept of 3. That happens only when x is bigger than 3. So 1, 2, 3. Here's our starting dot. And if we count out the slope, it's up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Maybe that's the same dot. Up 1 to the right 1. Trying to follow that same pattern. Up 1 to the right 1, up 1 to the right 1. So these are pretty close. They're not exactly parallel. Slope of 3/2, slope of 1, they look like they might be, but this one should be a little more to the right here. This one should be a little steeper, but just a sketch is fine. So this one's kind of hard at the end because these two lines should be really close to the same direction.